ways to figure out how distant stars are, how distant, we didn't know even galaxies existed at the time, but how distant galaxies are. And her idea had to do, because there are certain class of stars that get brighter and dimmer, and depending on how fast they get brighter or dimmer, they no no how long it takes them to get brighter or dimmer. So it gets, whether it's a fast pulse or a slow
Yeah.
pulse. The slower ones are brighter. I mean, the stars themselves are brighter, and the ones that change their brightness more quickly are just intrinsically dimmer. So once you know
So
that,
are we talking about like the Doppler effect and stuff then?
no, this is a thing called Cepheid variables. They're just stars that
Okay.
pulse. So
Okay.
some of them pulse quickly, and when they pulse quickly, the stars that pulse quickly aren't very bright. And the stars that pulse slowly, they're just brighter stars. Now, so that sounds like that's not important, but now you can look at them, and then you can measure how bright they appear in your telescope. Well, if you know how bright they were, and you know how bright they look, you can work out how far away they are. Just like if you have a torch, the torch, if it's close to you, it looks super bright, but if someone moves a kilometer away, it's very dim,
Yeah,
right?
I
So
see.
it's the same kind of thing. So if you know how bright the star is, and you know how bright it looks to you, you know whether it's close to you or far away. So
Okay.
she figured out how far away stars are using this trick.
Wow. Okay.
There's 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 another
That's
guy by the name of Vesto Slipher, which is a ridiculous name. And what he did is he noticed that some stars are moving towards us or away from us, and that is the Doppler effect, how he did that.
okay. Okay, cool.
So Edwin Hubble took these two bits of information, and he did a couple of things. First, he proved that the Andromeda galaxy is outside our galaxy. So all of a sudden, he realized that galaxy existed. And the other thing he realized is then he looked at many galaxies, and he found that most of them are moving away from us. And furthermore, the ones that are farther away are moving faster. And so he combined those two things to say, well, if if things are moving away from us and distant things are moving faster, that's when relativity gets in, because relativity says, well, okay, maybe things are expanding. But if you don't have those observation, you don't know
Yeah.
what has happened, because the universe could be contracting, or it could be vibrating, or it could be doing God knows what. But the
Mm,
measurement tells us that it is expanding. So now, if you know that it's expanding, then, well, if something is expanding, that means in the old days it was smaller. And if you take something like a gas, like air, and you compress it, as you compress it, it gets hotter and hotter and hotter. I mean, if you took chemistry class, you learned that
yeah,
compressed
of
things
course.
get
Yeah.
hotter.
Yeah.
And so then you just take it to the extreme. If you compress it down to tiny sizes, the whole universe, then it's going to be insanely hot. And so it's the observation that the universe is expanding that allows us to understand that it was hot in the past. Now,
I see.
knowing it was hot in the past is, of course, not enough, because, well, what happens when things get hot? Well, we kind of understand, water melts and it turns to steam, and maybe that if you get it really hot, it breaks into a plasma. But what happens before that? And the answer is we don't know what the hell's going on. So you need to take the measurements that we get from particle physics, where we smash things together and they are really, really hot. And so
Yeah.
now we say, aha, if the universe was hot, and we've measured what happens when things get hot, so we know what it was like back then. And so it's a multi-step process where you take information from many measurements, and you eventually work out and say, okay, at a certain point, the universe was so hot that protons didn't exist. Well, firstly, there was a time when it was so hot atoms didn't exist. And because the reason we know that is, if you heat up, say, hydrogen, and it gets
Yeah.
really, really hot, it just rips it apart. The electrons go flying around, the protons go flying around. It's not hydrogen anymore. And below a temperature, it's hydrogen. Above a temperature, it's not. So, we learned that there was a time where atoms didn't exist because it was just too hot. If we get it
Okay.
hotter then, we know there's eventually a time where
So
it's so hot. Go ahead.
yeah. Okay. So